Quadratic Inequalities by Megan, Kimberly, and Ashlyn. What is a quadratic inequality? A quadratic inequality is an inequality in which one side is a quadratic polynomial and the other side is zero. If you can look at the examples below, you can see that the y is acting as the zero, and the second part of the equation is the quadratic polynomial. For our first quadratic inequality example, it's in standard form. First, we can pick out the y-intercept in the equation. In this equation, our y-intercept is 4. So here we wrote the y-intercept as 0, 4. Next, we need to find our axis of symmetry. To do this, we use the formula negative b over 2a. We plug in our values for the variables and end up with negative 4 over 2, which equals negative 2. Negative 2 is not only our axis of symmetry, but our x value and our vertex as well. So to find our y to our vertex, we plug in our x value into our equation to solve for y. After plugging in and solving our equation for y, we get 0. So our vertex is now negative 2, 0. Now we have all the information we need. On the graph, we can plot our vertex first and our y-intercept. We can reflect the y-intercept point over the axis of symmetry to give us our point. In the equation, the greater than sign will be shown using a dashed line, and we will shade it above the graph. For our second inequality, it's also in standard form. We can once again find the y-intercept by using the last number of the equation as 0, 4. We find our axis of symmetry by negative b over 2a, plug in our values, and get 1.5. Not only is the axis of symmetry just for that, but we can also use it to plug in to find our vertex. After showing all of our work, our vertex is 1.5, 1.75. We can plot that on our graph as well as our y-intercept reflected over the axis of symmetry and shade below the graph because it is a less than sign. The line is solid because it is less than and equal to. Our third example is vertex form. For vertex form, you have to find the vertex by taking the opposite of b, which is negative 4, and c as it is. So the vertex will be 4, negative 1. Then you plug in 0 into the equation to find the y-intercept. Your work will be shown as 0 minus 4 squared minus 1. We'll get 16 minus 1, and your y-intercept will be 0, 15. Then you find the x-intercept by setting the equation equal to 0. By moving the 1 over to the opposite side, square root the 1, then you'll have plus or minus 1 equals 4. Then you could break that down into 1 plus 4 equals 5, and 1 minus 4, which will give you negative 3. 5 and 3 are the x-intercepts. Then you graph your vertex as 4, negative 1, y-intercept 0, 15, and your x-intercepts as 5, 0, and 3, 0. Draw the line as dashed because the inequality is not equal to, and shade as less than. How can we tell if the line will be solid or dashed? We can tell if the line will be solid because it is when the inequalities are equal to. We can tell the line is dashed because the inequalities are just less than or greater than. Graphing inequalities with the calculator. Steps using a calculator. Step 1, type your equation into y equals. Step 2, move your cursor all the way to the left. Step 3, change the line to either solid right corner or solid left. This depends on if the less than or greater than. 4, hit graph. 5, change window if needed. 6, find your max by hitting second trace or min, and then scroll to whichever is needed. 7, that will be your vertex. 8, if needed, find zeros by hitting second trace and going down to 0. 9, then graph and shade accordingly. Now, to review. We learned in standard form that your y-intercept is at the end of your formula as c. To find your axis of symmetry, you can use negative b over 2a and solve for your formula. After you get your x, you can plug it into your equation to solve for both x and y if needed, and that is your vertex. For vertex form, you find your vertex by finding the opposite of b and leaving c the way it is. Plug in 0 to your y-intercept, and also plug it in y to find your x-intercepts. solid or dashed line. Greater than or equal to and less than or equal to equals a solid line because of the equal sign beneath. Less than or greater than is a dashed line because there is no line underneath. When do we shade above or below the line? Less than, you shade below the vertex, and greater than, you shade above the vertex. Thank you for joining us on our review and hope you do well on your math test tomorrow.